if we are going to determine the moment here, no? This one is our previous problem, okay? We solved it before using consistent deformation. I just edited this, no? Let us springboard from here, no? Ano ba yung sunod? Ano to? Okay, so I will springboard from here, but before we proceed with the three-moment equation, we will first determine the moment here, no? Because we are only up to this, no? After determining the reactions, we determine this. So the distance between this one is the distance. This one is 30 over 20. 30 divided by 20. This is 1.5 meters. So this is 4 meters, so this one is 2.5. So if that is 1.5, we can solve the moment, no? 30 times 1.5 divided by 2. So this is 22.5 TNM. Now this is too big, so I will make it small. So may go siya, okay? I guess this is the same here, no? This is 22.5 TNM. Now, as to the maximum moment here, can be computed, no? We have 22.5 here, and then this one is 1.5 meters. So the distance from the zero shear to the midspan is 2.5. So this area here, the shear diagram is negative 50 times 2.5 divided by 2 is 62.5. That's negative. But we have a positive moment here. So we have it to plus it 22.5. So this one here is minus this is minus 40. I will make this small. 40, 12. TNM, no? So these are the moments. But when you are using actually tawag aning consistent deformation or force method, in this example, since I remove the reaction as I take the middle support as redundant. So the first thing that you will get is R2. No? So once you determine R2, you can solve for R3. Okay. And R1, R2, R3, if you know that already, you can do the shear diagram. Okay. And these are it. And then once you know the shear diagram, you can also do the moment diagram. Look for the maximum moment. So the shape of the moment diagram looks like this. No? But when you are using the method, the first thing that you determine are the reactions, then the shear and the moment. Okay. Now we will consider the same problem. No? We will consider the same problem. No? Using consider the same problem, shown above, no? Shown above. Okay. So that's it, no? So if we are going to consider the same problem, so we may a solution here, solution using three moment equations. So this is what will happen. So I will copy the problem solution. Okay. Okay. So let's go back. Okay. I will copy this. How to copy this? Okay, you have copy this. Okay, copied. Home paste. So I will drag this down. Drag that down. Drag that down. Okay, this is it, no? So that's the problem. That is it. Now, the distance between this is, I think, gamihan man ako siya, no? Ano ko ni siya, 12. I think siya din mo ni siya, 0.1. Then this one is 4 meters. This one is 0.2. And you have 4 meters. And you have 0.3. Okay. Above, you have, I think this is 20 kilonewton per meter. 20 kilonewton per meter. Ako lang po siya tumayon. Okay. Oops. Sorry. 12 today. Okay. Then I will copy this one. Home. Copy. Paste. And I will drag it down. Okay, that's it, no? By three-moment equations. Okay, so using three-moment equation, this is our lecture last meeting, and we have to solve an example. No, I will refer from it. I think that is our lesson last April 19. No, last April 8. No, I will try to see if it's there. You know, so statically alternate being using. This is not the one. I think we have lecture notes on laboratory, siguro laboratory provided team. No. Laboratory, April 12. Yeah, April 12. Okay, so that's not the one. Laboratory notes. Lecture. April 8. April 8. April 8. Oh, ito na siya. Yeah, three-moment equation. March 11, 2021. Three-moment equation. I have to check three-moment equation. Okay. So, actually, we have to use this equation. We have to use this equation. This one. Okay. Okay. Copy. Then I will go to. Okay, we will use this equation. Okay, so if you use three-moment equation, you have to use that equation. Three-moment equation. So we have to isolate this, no? To isolate this into this segment. Ito si 8BD segment 1, 2. The next, we are going to make a free body diagram of segment 2, 3. There are only two segments that can be made from this diagram. No, there are only two segments. Okay, there are only two segments. No. Ayun, this B. 16. Okay. So, may tabo na niya is ako yung kopyahon. Okay, I will place it here. Okay, so mao ni siya unang segment, no? Mao ni siya ang unang segment. Copy. We'll paste it here. So this is what appears in the first segment, no? So I remove that here. Good. It's the first segment, no? So here there is moment, no? Nani siya yung moment, no? Nani siya yung moment. M1 alin to. Okay. Nani siya yung M1 din yung magbuhat agad itong kuhaan. Nagbuhat mo ba ito? Oh yeah, this one. Copy. Yeah, so I will shake this. So, yeah, no, ako lang siguro iisip ko na. Okay, so I will copy that. Copy and paste. So, paste na po niya. Ako na siya. Ako sa yung clip vertical. So, I will call this balik. So I will call this one as in2. I think this one as in1. Being I will call here in1. In1 so in1 siya. So I will on this one, I will make a subscript and I will copy this, copy, put it here, paste, paste, and put it here, and model that is into. This is the unknown, okay? And this one here, I will make an arrow here, insert arrow, this one. Okay, I will make that color red. And then maybe I'll make that bigger. I see it. Okay, there's one. I will copy that and paste again. Now this force exists really, no? Only at 1 to 2. No? So I will call this one as B at 1, the shear at 1, and this one is the shear at 2. Shear 2. Okay, let's go. Shear 1 and shear 2. Okay. So, okay, and then the second free body diagram looks like this. This will be the shape, the shape of your second free body tutor. Copy. Then I'll go back to my notes. Post it here. Put it here. Okay, so this is tutor. So I will put this one, copy, paste. This one as your into, and then this one is your paste. And now this one is copy. Home, copy, paste. So this one is into, and this one here is into. Then I'll have to copy this one. Copy, paste. So that's a brother. Ano siya kabuo? Call that as B3. This one is B2. Okay. I'll call this B2 and then this one as B3. So take note that the subscript actually coincide with the point they're acting. They are thinking. Okay. So using the three-moment equation, we have this. So we know that from here, M1 is 0. Okay? Tao na kayo kay pin mo na siya, no? So M1 is 0. Okay? M1 is 0. But not M2. M2 is not equal to 0. M2 is insert natin symbol not equal na siya. Not equal to 0. So simple lang into. So just hit that as into. Okay? Into is not equal to 0. Similarly, in the secant diagram, into is 0, but we can see that in3 is 0 because that's a pin, that support moment. Okay. So those things are we know. So in using three-moment equation, using the three-moment equation, from here, we have 0 plus 2 M2 plus L1 plus L2 M3 L2. So that can be we'll have to copy it again. Copy. So I paste them in. Okay. So we have 0 times 4 plus 2 M2 times 8 because L1 and L2 is 8. Plus 0 again times 4 is there is a plus, no? There is a plus. So plus 6E1 gamay 1 divided by 4 plus 6E2 B2 divided by 4, no? The 4 there are L1, so that's equated to 0. Okay. So we just leave this as L1, no? We just leave this as L1, L2, no? So I put a subscript. This one is 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 a subscript. Okay. So we have this one is also subscript. So we have simplifying, that's 16 into plus, no? So we are going to determine this, no? We are going to determine this one. We are going to determine that, no? So determine that. Okay, determine that using the one, no? This one. There are figures, no, that I given, especially for the value of the 6E1. We have different types of loading now. Now this is case number 3, no? So I'm going to show this, no? This one. So we have a uniform copy. So we have we'll put it here. Okay. So this one is the column for the load case, no? And this one is the 6E1 times A1 divided by L1, no? So mauna siya ang value niya dinhi. Ang isa mo ni siya 6E2 times B2 divided by L1, no? So mao ni siya, no? Practically. Diba? So sa segment sa aning ako 6E1 ano natin is equal to WOL cube divided by 4. So W is negative 20. No? I use negative because it's going down. Then L cube is 4 times 4 times 4. 4 times 4 times 4. That is 64. Okay. Then divided by 4. So you will have minus 20 times 64 divided by 4. That is 64 divided by 4. That's 16 times 20. Okay, negative 320. No? Negative 320 na siya. Ano ba ito? Okay, negative 320. Ang bagyo na niya. Now, let us see the unit. Let us see. We'll not consider the unit. And 6 into D2. Copy. Okay, we determine that one. That is equal to, we will use the equation. No? I think they will have the same. Negative 20 times 64 divided by 4 is equal to minus 320 again. Wow. Minus 320 again, no? 320. I think the unit here is kilonewton meter, no? But anyway, we are consistent with the unit, no? With the other. So, the sum of that is equals to should become minus 320 and then minus 320 again is equal to 0. So into here, into, so if you want to determine into, copy, into space is equal to that is becomes positive on the other side, 640 divided by 16. So into is equal to the unit is KNM, no? 640 divided by 16, 40 divided by 16 is 40. 14. Okay. So once you know the moment, no, you go back here. You go back here. So we are going to sum up summation moment at 2, no? At 2 is equal to 0. Okay. So this one is a subscript and this one is a Greek letter. Oh, okay. So if you sum up moment at 2, no? Now we will make sign convention, no? See, positive counterclockwise. Okay. So this will be our pivot point. So into actually into wow. Let me one. Okay. Yeah, positive din siya. Positive din yun. This is positive here. This becomes what I mean, this one. This one is positive, no? Yeah, is minus 20. Okay. 20. Because of the sign convention nga akong gigamit. Okay. So this becomes minus 640 and this is negative 40 here. So for this particular sign convention. Now we sum up moment about 1. So into is negative, so meaning that it is clockwise. So we start at negative 40. Then we have minus again, V1 multiplied by 4. Then we have positive 20 times 4 times 2 is equal to 0. So this is V1. So we can solve for V1. V1. We can solve for V1. And that is equal to 240 times 4 times 2 is 962. 20 times 4, that's 80. Times 2, that's 160. Then you have minus 40, you have 120 divided by 4. Okay, so you have 30 TN. Okay, 30 TN. So, you have to sum up forces y equals to 0. So what you will have is V1 plus V2 is equals to 20 times 4. So you have V2 is equal to 30, the total load is 80, so that's 50 TN. Okay, this one is a Greek liter, symbol, then this one is a Sanskrit, and it's a subscript also. Subscript is here. Okay, only after you do the three-moment equation, so that you will know what is into, that you can go back here, because in the equation this will become m2 minus b1 minus ano may equation yan, anak ko may equation niya. So if you do not know m2, you still not can proceed, no, because you have to do b1. So what we did is we substitute the value here in the three-moment equation, that we able to solve for the moment at 2. Then once we solve already the moment at 2, we go back here. So B1 can be solved, also B2. So from that, we know already B1 and B2. No? So now using the segment number 3, using this, okay, I will align that. Okay. That one. So we use the same trick, no? We use the same trick. This one. Copy. Summation of moment at 2. Using that one, no? Summation moment at 2, counterclockwise, but knowing that one, no, B2, counterclockwise. So here, this is positive into minus into, then times minus into, then we have increase 0 already, we declare that as 0. Then we have B3, this is positive B3 times 4. Then you have minus 20 times 4 times 2. So into here is counterclockwise moment, so this will become positive 40. Then we have positive B3 times 4. Then we have minus 20. Then we're able to solve B3, no? B3, so the 20 times 4 times 2 will be converted to will be transformed to the other side. 20 times 8. Then you have to minus 40, 120 divided by 4. So this is 30 kilonewton. Then substituting summation force is y equal to 0, you have b3 plus b2 is equal to 20 minus 4, so that will be able to solve b3. So in other words, you will have a diagram that is like this, no? You have a diagram that is like this. Okay, that is the one. I will make that bigger. Okay, then I'll borrow this one. Home, copy, paste. So put that here. Okay, so that one. Then I will copy again. I will make that mini. Paste, paste. So this one is the one at point 2. This is at point 1. You have also point 2 here, no? This is 4 meters. This is 2. You have 4 meters here. Then we have 3 here. That's point 3, no? So at point 2, actually there are two of them, no? There are two. One for segment 1, 2, and the other one is for segment. The other one is for segment 2, 3, no? So ato na ingnon niya duha na ka buok copy. Is duha na ka buok siya. Duha na ka buok. Duha ka buok B2, no? So one of the B2 butangan sa nato upload. Butangan sa nato upload. Okay. This one is that way. Okay, ato na siya i-fill pattern. Ini akong gusto mo. Kaya color niya. Okay. Color. Okay. So this is 20, no? This is 20. 20. EN. Ito na siyang gamayon. Okay. So, mga na siya, no? Hindi siya ito siyang gamayon siya. Okay. This is point 1. Point 2. So this one actually is equivalent to 30, no? 30 PN. This is 30 PN. 30 PN. This one will become 100, no? Because there are 250. 50 ba? Oh yeah, 50. So the first 50 is for segment 1, 2, and the second 50 is for the 2, 3. So basically this is 100 PN. No? They are all of the same direction. PN. Then the other one is 30 PN. 30 PN. Now we can do the what we call this? The shear diagram, no? Shear diagram in this manner. Okay, that's the length. Okay, so I will make that bigger, and I'll choose the color. The color, okay. Then I will insert a sheet one. So that one. Okay, and then copy that. This, and I will flip this vertically. Butang pa natin din here. Okay. This one I'm going to flip that and straight, maybe horizontally. No. Copy that one, copy and paste. Then I will flip this one. Rotate. Left vertical, left horizontal. So this one is like be there. Okay. So we can put here. We can put here. Put here 30 pm. No. Then we have at negative 20 times 4, that is 80, that's going down between 1 and point 2. So point 2 here will become negative 50. This is negative 50 kn. But there is a 100 kn, so that brings back to positive 50 here. Positive 50 kn. Okay. Then I have to copy this. Copy and paste it here. Oh. Okay. So this one here is minus 30 kn. Yeah, so this is the shear diagram, no? So this is the load diagram, load diagram, load diagram. Then what do you call the next one? This one is the shear diagram. But here it's different, no? It's the moment that is determined. The other one is the reaction. Okay? Next is you can do the moment diagram. No? Moment diagram. Pull this up. Pull that up. Pull that up. Okay, we have space now. No? Okay, so we have moment diagram. Okay, so you have to copy that, copy and paste. Okay, we have zero shear here. No? The distance between this zero shear can be determined by dividing this number with the load. No? So, for example, if this is 30, divide that by 20. So, key in will cancel and the meters and the unit will become meters. No? 30 divided by 20, that is basically 30 divided by 20. You have 1.5, so that means that this distance here is 1.5 meters. Now, this distance here, there to there, is you have 50, no? That's 50. 50 divided by 20, so that's 2.5. So that means that this is 2.5 meters. This distance from here to here. Okay. I think on the other side the same, no? So actually you can have a maximum moment here. Okay. You have a maximum moment here. And also you have a maximum moment somewhere here, no? Everywhere there's zero shear, there's maximum moment. So somewhere here there's zero shear, so that's maximum moment. So we don't know how much is that. So I'm anticipating a negative moment. Okay, and then this one is copy again and paste. So I'll have another maximum moment here because you have zero shear. Okay. Now maybe I will change the color of the negative, so I can change the color of negative by changing the color into this. So all red one are negatives, no? So other are using this one, no? Using that one. Okay, so that is just stylish, no? So this one is a positive, so you will have a positive moment. No? So your diagram will look like this. No? Wala mo good siya parabola din, so I will just use the curve. No? This is the tagbutang color nila. Okay. I'll just put it here. Okay, so muna siyang moment niya. Ako lang yung gamay yun. Moment niya. And the magnitude of that moment is 30 times 1.5 divided by 2. So 30 times 1.5 divided by 2. That's positive. That's 22.5 EN. And I guess that's still the same here, no? I will just anticipate the 22.5 EN. Now, this distance is it's 2.5, but you have negative 50. So the area of your shear diagram actually is 50 times 2.5 divided by 2. That's negative 62.5. But you start from 22.5, so the equation will be 22.5 minus 62.5. So you'll have 40 here, no? You'll have 40. I will insert a shape. Yeah, I have 40 here. Sayang. Hindi mo. Insert. Okay, wala perfect, no? So, anyway, sakayin mo na siya. So, here, you'll have minus 40 ENM. Okay? Now, you have a positive area here. So, if you want to determine this distance, so you have 50 divided by what is the load above 20. So, that means that this distance here is 2.5 meters. 2.5 meters. And then, ang distance din sa pit is 1.5 meters. 4 meters. Now, you have a blue one, so that's a positive. So, you can insert shape here. So, okay, so that's it like that, no? So you have negative 40 times 62.5 equals to 22.5. And then you have another negative area, 1.5 times negative 30 divided by 2, that is 22.5. So, ano yung gagawin, no? Okay, so here, you have 0, and then 0 here. These points are 1, 2, and 3. So this is the moment diagram, no? So as analyzed using the 3-moment equation, no? Using this one. Okay, so muna akong gigamit ka method, no? And we found out that the one that we solved before is the same, no? We have the same, no? Only that here, this is using method of consistent deformation, and what we get first is the reaction, because we let the redundant support as the reaction as the redundant support, particularly the middle reaction. Here, we are using 3-moment equation, no? Consider the same problem using 3-moment equation. So we satisfy the moment equation actually here. Okay, so like that. So this is the answer, no? This is the answer. Okay. Now, okay, so okay, so that is the answer, no? When we analyze the statically determinate structure, and then we use the moment equation, so we have only 2 span, no? 2 span. So we can use easily the 3-moment equation. Now, what if there are 3 spans, no? Three spans. So meaning there are 2 other supports in the middle. Okay, so you have to use the 3-moment equation in this manner, no? So I am going just to give you we have another problem, no? Another problem. So, say problem 2, problem 2. So, what if kung ani ang iyang kuan, ang iyang using 3-moment equation. What if ingon ani ang iyang diagram? What if ingon ani ang iyang diagram? Okay, so I make that bigger and then change the color. What if ingon ani ang iyang diagram? Okay. Okay. Copy that. Then there are two add more supports. So one here. Actually, we just this kind of problem is we solved it already, no? Using method of consistent deformation, and then we just try to solve it again to check whether the answer agree with the previous solution that we have. Let's see that this is 4 meters again. 4 meters. This is 4 meters. This is 4 meters. 4 meters. Tawag di ano nyo. Ano siya 0.1. Ano siya 0.2. Oops. 0.2. Balik na. Then you have 0.3. And then you have 0.4. Okay. Ito siya ang loading niya. Maulang gihapon. No? Maulang gihapon ni siya. 20 lang gihapon. It's going down 20. Okay, and then so may fill at the Newton pattern fill. Yeah. Okay, okay, so that's it, no? So this is 20 PL per meter. Okay. One of this is we will just write it. This is pin. This is roller. But the horizontal support for the pin is useless here because there is no horizontal loading. No? Although the function of that is just it will hold the structure so that it will not roll. It will not move. No? So if you pin your structure as in pin, your structure will not move horizontally. No? Why? Because it's thin. But if it's all roller, so well, it's not move without force. But if somebody just push it, no, so it will roll, no. So, and then also, if you are analyzing it using computer, any structure that is unstable, will not give a solution. No? So to make it stable and at least you have to make it in equilibrium, no? You have to make it determinate, but most structure are indeterminate. Okay, we have solved this already, no? Previously, if you still remember, but we are going to solve it again using 3-moment equation. So this is the trick here, no? So in the 3-moment equation, duha gid ka span ang imong magamit, no? Kay sa mao man to, no? Katong equation niya, no? Ang equation niya actually is animal, no? Ini mo man siya, no? Kung copy. So, kung mauna siya ang equation yung gamiton, imuan o ginto lang, no? So, kinilang o kana siya, no? Na siya. So, ang buhaton na tuwa na niya, no? This is the method, no? Yes. Ini sa atong i-consider first. Kana siya to i-consider. Okay, and then okay, ini sa siya to i-consider niya. Pagbuhat ang equation na di sa nato ni bali-balihon ng isa, no? Di sa bali-balihon ng isa. Okay, so in the second, ini na sa dayon. You move one span to the right, no? Dili tag two span, no? So if you are working in this spans, spans 2-3 and spans 3-4, you have two spans, so this one will still apply. But unsay mitabo sa mga subscript, natural kini siya mahimong M2, kini siya mahimong M3, kini siya mahimong M4, and this one mahimong L2, kini siya mahimong L3. This one is L2, nahimong L3. This one is 6E2, this one is 6E3. Ingana na siya, no? So, may tabo na siya. So, ingana ang may tabo niya. So, we are going to procedure. Apply three-moment equation to spans 1, 2, and 2, 3. Okay? Anain mong paano na, no? So, doon na kay segment, IPD, FBD, segment 1, 2, doon na sa kay FBD, segment 2, 3. Okay. So, pag human na mo ang anak niya, wapa ka na human, no? So, balhin na sad ka. I-move na sa mo one span to the right. Okay? In that case, imo na siyang utuhon. That means, imo na siyang utuhon. Uto na siya. Pero, mausab na ang iyang subscript. Okay? 2-3 naman siya. Span 2-3, 2-3 ba? 2-3, yeah, 3. Then 3 to 4. 3 to 4. And this one is 2-3. 2-3. And 2-3. And 3, 4. Okay, no? So, what happened is that kung mauna ang imong kuan, so atong ato na siya kunon, singani mitabuan na niya. Oh, that's the problem, no? Okay. Okay. Ako dito kita ang ganyan. Window. So, mo ni ang yung ganyan class, no? You still remember we solved this kind of problem, no? Giduhan nato, no? Giduhan ang anong. You solve this using consistent deformation and we have solution already. Okay. Now, ang proposal nato ni karon is to use three-moment equation mo niya itong gamiton. Okay? So, yung nga ang trick ani niya class, no? So, ako magay kung kalayo ganyan, may gali kay gibatindog ko nga wala pala ako na present ang akong blackboard, no? Whiteboard. So, nga ani ni siya. So, duha ka span gyud dili na nimo mong tulo, no? Kay ngano ang gikuhaan og basis ana niya katulad man yung duha ka span. So, duha gyud ka span. So, here, you are working 2 spans at a time. Then, after you have done that, you move 1 span to the right. So, again, pag move mo, duha lagi apong ka span, pero doon na bagong span nga nagamit nimo. Ang daan, pwede lagi apong to nimo siya, no? So, we start here, no? So, tungod kay tulo na ka span. Katong ganyang example, duha mong gud siya ka span, no? Kita na to siya. Kana agad siya, no? Kana siya. So, sa theory sa three-moment equation, duha agad niya siya ka span. In fact, mo agad na equation, no? So, M1, 2, and 3, no? Refers to point 1, 2, and 3, no? And then the 6E1 and 6E2 will be the 6E1 and 6E2 of the load on spans 1, 2, and 2, 3. Now, we have already solved this. Now, the question is if the structure becomes longer, just like this. Okay? No, not that one. Like this. So, there are 3 spans now. So, can we still use the three-moment equation? The answer is, of course, you can. No? How? So, you have to consider 2 spans first. No? So, never mind this one. No? So, do not look into this. Only the first 2 spans. So, here, you apply three-moment equation on spans 1, 2, and 2, 3. Ayaw sa ng 3, 4, no? So, ang steps mo, gihapon, mo free-body diagram ka sa segment 1, 2, mo free-body diagram ka sa segment 2, 3, and then fill the moment equation here, no? So, here, makita nimo nga ang M1 is 0, but M2, and M3 is not equal to 0. So therefore, we cannot say that they are 0. No? So, in other words, duha na sabog ang unknown na ay into na pag-entry. So, muna siya. Into na pa-entry. Okay? So, your equation then, so if you substitute, it will be 0 plus 2 into, then you have to multiply it by 8. Then you have plus entry times 4. Okay? Then nakakay plus. If we are going to consider the same loading, so we still consider this one. No? Home copy. We still use that one. We still use this one. Okay. So the other one is for this one, and this one is for that one. No? So this one, if W is 20 and L is 4, so this will become positive 320. No? Positive 320. That's for this one, and the other one is positive 320 is equal to 0. So in other words, you will have this equation, you will have 16 into plus 4 into 3 is equal to minus 640. Okay? Okay, ato buta subscribe. Ya karon kay duha may atong unknown, isa man kay equation. So mapadayon pa ta. So there's no reason to stop, no? So this time, actually kung but niyo hunahon kini siya, ako sa din ko na. So mo ni siyang hitabo karon na kay diha okay. Pati body diagram nimo mo ni siya labas. Mo siya. So wala na siyang kuan. Putaran og mga simbol, no? Ang mga simbol. Then ang isa dayon mo. Okay, may sikat yung diagram. So, ano siya, no? So, unsa man ang imo og ito, pihaw na sa din. Ang tulis sa ito. So, so nakaka na. Hindi na. Hindi na. Okay, so muna siya imuan. Imuan. Okay, imuan na siya. So, taas ko pa. So, imuan. So, siya ito. Yeah, aside from that. Siya So, siya, no? So, nanataan eh, 640. Okay, apply three-moment equation to M2. So, we still have to make free body diagram segment 2, 3. So, this is what happened, no? Apply the moment equation. So, segment 2, 3 is morning ako. Balik niya siya. So, kaya ito yung 4. Hindi na niya siya. Hindi niya sa 3 and 4. 3 and 4. Three, 4. Ini siya, mabalik niya siya, no? Mabalik niya siya. Mabalik niya siya. Patuloy siyang i-group. So, this one is still the same. Still the same as diha. Okay. So, diha. Siya pa kaya ako ito. Okay. Then, din man siya. In 3. And this one is in 4. Then, din kay dito, dito. Yeah. So, magpiang ko na siya. Copy, paste. So, dapat yan. Then, pagpiang mo. Then, mo siya. Then, siya. Emission D3 and D4. Okay. Applying the three-moment equations, this is this one. Copy. Then for segment 2, 3. So this will become, so M1 here will change this. There will be change subscript, not change subscript. Change subscript. Okay, add one. Like for example, into. So here, into here, into and into cannot be cannot be 0. But M3, M4 is clearly 0. Okay, so those are the things that we can uh, conclude from the diagram. Okay, so like that. So here, this will become M2. M1 will become M2. So you have 4 M2. Then you will have plus 2 M3. M3 times 8 because L2 and L3, L2 and L3 is 8. Then you have plus 0. No? That will become M4. M4 is 0. Then we have another plus 320 because it's same loading. And then plus 320 again. Then this is equal to 0. So in other words, you have, this is 4 into this into. So you will have the second equation of 4 into plus 16 into is equal to minus 640. Okay, so we'll change this one. So we have two equations actually. We call this as equation 1. Equation 1. Then this one, we call this as equation 2. Equation 2. No? So in matrix form, if you are used to matrix, so you will have an equation like this. Okay, equation, insert equation. Okay, it will be like this. Okay, so you have 4. Okay, this will become 16. You have 4. You have 4. It's 16 times quantity. This is 10. 2. This is 10. 3 is equal to negative 640. So it will be like this. In matrix form, no? Like that, no? So you're going to solve for into an entry. Just inverse the pairs, no? So we'll solve into an entry. We solve into entry. Okay, into entry, solve into entry. So we have this one, edit, copy, and then put here, edit, paste, so into is equal to this, no? We'll have a matrix here with 4 by 4, with 4 by 4. Okay, this one will be 16. This one will be minus 4. This one will be minus 4. And this one is 16. Then there is an over here of 16 squared. 16 squared minus 4 squared. So it's gonna be like that. No? So we have edit, paste, no? So 16 times 16 minus 16, you have 240. So 240, you have 640 times 16 minus 16 minus 4 times 640 divided by 240, 32, no? Minus 32 EN, 32, 32, okay? So, 640 times 12 minus 16 times 16 minus 16 minus 4 times 640 divided by 16 times 16 minus 32. So this is it. So that's the solution. No? So that becomes 32 and 32. Okay. So I will save this. Okay. And then okay. So that is how you are going to do, no? If you have a problem like this, first you perform three-moment equations here, then next you perform a three-moment equation by moving this forward, no? Because three-moment equation involves only two spans, no? Two spans, no? So even if this is longer, you just continue going, no? But that's it, no? It will be more laborious to do, no? Like that. But at least you can solve statically indeterminate structure using three-moment equation. And this is fastest, no? If you know this one, if you have some table for what's the value of this one. Okay. So this is our lecture this afternoon. It's about three-moment equation as applied to statically indeterminate structure. No, two types of indeterminate structure. One is has a statically determinate to the first degree. Another one is a second degree. What's the difference between them? The first degree has only one equation, and the second degree has two equations. So that's how we do it. So okay, so I will upload this class as our lecture today, and next meeting we will have an exam. The exam is actually not this one, but the method of consistent deformation. So, okay, karon mo to, pero wala ko naka-prepare. Okay, so I will stop sharing. So, ingat mo na siya class, no?